Hi, everybody. Now that we've computed a perimeter of uh, the frontier of wild to human settlements, we have a perimeter in some part of the world, as shown by our script that we simulated. Then we can ask, well, what's the frequency or the probability of a jump from a virus to humans and then spread amongst humans in of a virus or other microorganism. So we want to get an idea of what's that probability of a jump over. And we could say, well, for every 1 kilometer of frontier and the perimeter of wild to human settlement, for every 1 kilometer, there's a 0.00001% chance per year of a virus jumping over. So that might be the kind of number that we're looking for, but we really are nothing in our economics training has any preparation for thinking about what's a reasonable number to think about there. So I suggested in your problem set that you use AI. So let's jump over to some AI prompts. And here is Gemini. Um, and I prompted Gemini, what are some academic ecology estimates of the jump rate per year of virus from wildlife to humans at the wildlife settlement frontier? Um, and it gives me a very reasonable answer. This is a challenging task in disease ecology. Uh, Many of the spillovers aren't detectable because just one person or a few people get them and they're not unrecorded, especially if they die or if they get sick and recover, it might not be recorded. And then the answer from Gemini continues to suggest that the rate of spillover is higher than what is likely recorded in clinical databases. Gives you a link to something. Now, is this hallucinated or not? You'd have to do some more research to find out whether this is hallucinated. So this suggests there's hundreds of thousands of spillover events. Of course, we're not interested in the spillover event that you got a fungus that got into your toenails and was slightly itchy. That's not the kind of spillover event that we're thinking about. Um, we want something more significant. So here's a study, hallucinated or real, I don't know, from Nature, suggesting that there's 66,000 bat-related SARS spillovers every year. How many of them are all the same spillover? How many of them are different SARS coronavirus spillovers? Again, have to do a little bit more work to figure this out. In these frontier areas, the rate is highest due to propagule pressure. So maybe now that's some vocabulary to look for. Um, what even that means, bushmeat and wildlife excreta, it's obviously important. Then another way to think about this is what's the pool of potential viruses? So there you could go and do microbiology studies and not worry too much about what actually jumps over, but what's the potential for jumping over. So you do random sampling of wild ecologies and think eventually humans are going to come here. So how many viruses potentially are there here that could jump over? So these numbers vary a lot according to the AI. Um, and so here we get an annual emergence rate at 2 to 3 new viruses per year. Notice what this doesn't say is according to a perimeter. So it's not, is this for the whole world, or is this for the one perimeter that we're thinking about? And that gives some other, excellent background into this. Always likes to do these little tables and let's further prompt it to say, what would the rate be per kilometer of frontier in a specific wild area with settlements? on average. Let's see if it does anything with that. If it gives us some, now it just hallucinates an answer. It says that rate per kilometer is risky, but high resolution spatial modeling has provided some densities that ecologists, so somebody's doing this. So again, points to some studies, um, points to numbers of spillovers. It's calculating this per square kilometer, not so much for the frontier. And then here we go. Here, if you were to walk 100-kilometer stretch, here's the here's the uh, this is in some sense what we want. So we want some little bit more research into this, but it sounds like we're starting to get um, better idea of what this jump rate would be. Um, and then we get some, other modeling efforts to do this. Yeah, here's, this is a nice modeling uh, sense. This is what we mean. So let's take this original question, and now let's jump over to Chat GPT, and I'm going to say jump rate per year per kilometer virus from at the wildlife settlement frontier. Yeah, let's see what ChatGPT does. And it suggests surprisingly few that estimate a literal spillover jump rate. In units. These are the units, right? So now we have zoonotic. We get some of that vocabulary, which is good. Um, and we see that the academic literature isn't really giving us what we want, which is if as long as ChatGPT is reasonably condensing the academic literature. Um, Rare locally, common globally, low probability event. That's okay because we have a very, very big perimeter. Um, so then it starts giving us these kinds of conversions to frontier type thing. So this is pretty nice. Um, it's explaining this how it might work. So you can start working from this a little bit. And then let's go and copy this and go over to Claude and ask the same question to Claude. And let's see whether Claude gives us something really different. All these seem to be, it looks like a whole bunch of citations is what it's looking for, and then absorbing those before it and Claude is, sycophantic as usual, treating your question as if it were a really, really good question. Genuinely, you're at the frontier here. Um, that's its general tone. Um, so, global scale, emergence, spatially explicit risk maps, per a risk per grid cell, but not really at the frontier. We get that zoonotic spillover risk, so that seems to be an important terminology in this literature. Uh, Claude mentions Ebola. I don't think the other two mentioned Ebola, which would seem like the most relevant for us. Um, Gives some links, apparently. So got some links to that. Lassa fever, another really important lethal virus in Nigeria. And yeah, so we get a bunch of citations. I would say Claude looks like it's giving a good and a good explanation of why such a per kilometer frontier doesn't work, and then you get a back of the envelope. So very nice with some quotes. So across the three AIs, we certainly get the vocabulary that we need for calculating some of that. We get some ideas about what the range might be. If we're going to calculate the risk of this, we need some idea of the range, and then we can start calculating the risk.